Welcome everyone to the latest emissions analytics webinar on the route map to net zero construction. My name is Nick Molden. I'm founder and chief executive of Emissions Analytics, and I'm delighted to welcome this morning to our webinar Mr. Daniel Marsh, who is the Programme Manager, Centre for Low Emission Construction at Imperial College London, and Dr. Carl Desouza, Research Associate also at Imperial College London. Now, we've been doing real-world emissions testing since 2011. We've done vehicles of all shapes and sizes in all sorts of places around the world. With Dan and Carl, we've gone into some of the most difficult locations, some of the coldest, wettest, muckiest places to test construction equipment of all sorts. So what you'll see today is the fruits of a huge amount of research that they have led with us. And so I'm really looking forward to this, and we will run the webinar in the same usual format of presentations from Dan and Carl, but then some time for questions at the end. So without mucking around, Dan, over to you.
Hello, everyone, and thank you very much for joining us this morning. Before we get on to the meat of the webinar, I wanted to give you a brief overview about who we actually are, because I'm sure some of you we've worked with and worked very closely with, and some of you are probably completely new to the Centre for Low Emission Construction. So we form part of the Environmental Research Group, which in itself sits within the School of Public Health at Imperial College London, and previously we were part of King's College London. So you may be aware of the work that we've done around other pollution sources and ambient air quality across the UK and across Europe. The centre itself is a centre of expertise. Its objectives are to raise awareness of the air quality impacts from the activities and machinery used in construction and demolition. We create that high quality scientific evidence to inform policy development. We work with manufacturers and industry partners to develop solutions, and we work with understanding the exposure to workers on site and to the public around the sites. And all of this information, all of this evidence is then made available back to planners, air quality professionals, and to the industry, as well as government bodies. Okay, so we're going to frame what we're talking about today and framed it as the diesel challenge. So as a sector, globally, construction is responsible for about 39% of carbon emissions. So it's a huge contributor to this problem that we're now trying to solve. In the UK itself, that equated to about 11.4 million tonnes of carbon dioxide emissions in 2020. So this is the challenge that we've got ahead of us, is how do we go from that to being net zero, and what does net zero mean? Well, I'm sure many of you are aware the UK government is committed to be carbon net zero by 2050. But the challenge we have is we currently have about 300,000 pieces of machinery out there that are running on diesel. And these range from the very small machines, handheld machines and tools on site, right through to the giant machines, the giant cranes, and those piling rigs that are putting huge holes into the ground. So it's a very complex problem, and there isn't going to be a single solution that's applicable to every machine that we're dealing with. And on top of that, the sites themselves, the construction sites themselves, often require power to be supplied from non-grid sources. So they're moving across to using diesel generators, and that in itself is delivering something about 2.5 million tonnes of carbon emissions in the UK based on the 2020 figures. And then again, on top of that, we've got the supply chain, many of which is using diesel HGVs to bring the materials to and from the site. When we're looking at the carbon challenge, we can't forget the fact that it's not all about carbon. Okay, so the challenges that we have at the moment are very much about climate change, but also that impact, as I mentioned before, on workers and people living and working around the sites, and that public exposure risk. Air pollution itself is recognised to be one of the greatest environmental challenges that we have. The combined effects of air pollution globally is estimated to take about 6.7 million lives prematurely every year. So this is an emergency as far as the World Health Organization are concerned. And so when we're looking at solutions for the construction sector, it's not just about carbon, it's about reducing those local air quality impacts and health impacts that are associated with it. And very much so, the Chief Medical Officer in the UK, Chris Whitty, his annual report in 2022 focused specifically on air pollution and highlighted the impact from the construction industry. So this is a challenge that the government are aware of and the medical side are very much aware of, that we need to be dealing with, and as rapidly as possible. So when we talk about a route map, it's what does that look like and what does it actually mean? And so this is a very simplistic view of the sort of stepping stones as we see them at the moment to achieving the challenge of removing those carbon emissions from the construction machinery, from that fuel burn. It's not perfect, but it makes up for where there's maybe not a clear regulatory pathway coming through from government as to where we are now and where we should be going as we move forwards. We start at where we are at the moment with the diesel use. We have those early solutions that we're seeing coming through at the moment, and we are looking at changing efficiency, using best practice on the sites, delivering the technology and the training to go with the technology to remove or to reduce the fuel consumption. But ultimately, we need to move towards this diesel-free end of the stepping stones, and then look at the landscape beyond that and say, what do we need to do next? Now, at this point in our webinar this morning, I'm going to pass over to my colleague, Dr. Desouza, who's going to talk a bit about the trials and the research that we've been doing at Imperial, some of the challenges and some of the outputs from those studies. Thank you, Carl.
Thanks, Dan. So the previous slide gave an indication of the stepping stones of how we move from diesel and moving away to utilizing diesel and a diesel-free construction site. At the bottom of each slide, we can see an indication of where each project is along those stepping stones. This trial, Alternative Fuels, was started out and carried out in the spring of 2021. The aim was to demonstrate the potential air quality benefits from using alternative fuels instead of standard red diesel. Two machines were tested, a stage 3B excavator and a stage 4 excavator. For both machines, the results indicated minimal air quality benefits from the measured tailpipe emissions when compared to diesel fuel. However, there could be potential carbon benefits through sustainable sourcing of such biofuels. Exhaust gas after-treatment technology is more effective at reducing these harmful pollutants from older machines. Another trial we carried out was the exhaust retrofit technology. Here we successfully demonstrated the benefit of retrofitting Balfour Beatty's two older stage 3A piling rigs with Eminox's after-treatment technology. The tailpipe emissions were measured by emissions analytics using portable emissions measurement systems. Here, the results indicated emissions were reduced well within the latest EU Stage 5 NRMM emission standards, which led to the technology being certified by the Energy Saving Trust for both medium and large engine family sizes. This allows for an industry-wide rollout of technology across the fleet, which will benefit the environment, the workforce, and the local community through improved air quality. An energy storage recovery system, so punch flybrid technology, is used to capture energy from an engine that is normally wasted, and it stores it in a flywheel. This energy can be recovered and used whenever needed, allowing for rapid ramping of power within a dynamic range. In the construction sector, an ideal application would be a tower crane performing a lift. Usually these cranes are coupled to large gensets, which are capable of providing these peak powers whenever needed. Such large gensets can be replaced with the punch flybrid technology coupled to smaller generators, thereby allowing for downsizing, which in turn allows for reduced fuel use, higher costs, and reduction in associated emissions from these smaller generators. In this trial, we measured the benefits of downsizing these large generators and utilizing the punch flybrid system with small generators. An energy management system developed by Invisible Systems, Balfour Beatty, and Sunbelt Rentals. The EcoNet energy management system actively controls to reduce energy output from non-essential assets when there is a power demand spike. This enables downsizing of generators to more efficiently match site power requirements with generator size. This is an ongoing trial where measured emission factors are going to be coupled with the site profile activity data to demonstrate the benefit of utilizing the EcoNet system with the downsized generator. Moving on from energy efficient solutions to cleaner energy production, a low emission power generator, the Aquafuels engine runs on glycerine, which is a byproduct of the biodiesel manufacturing process. In this trial, we tested a generator with a constant load output operating on glycerine fuel. An application of such technology is a site where the power requirement is fulfilled by a battery hybrid system. Now, since the generator is operated at its maximum load to charge the depleted battery, the engine is running at its most energy efficient and emission level. Another example of clean energy production is the clean air gas engine, CAGE, which is powered by Oaktech Technologies, is an Innovate UK and BEI's red diesel replacement innovation project. These CAGE generators run on liquefied petroleum gas, LPG, as well as hydrogen. So they are current and future-proofed, since these dual fuel engines operate based on fuel availability, either LPG or hydrogen. Off-grid power generation is the single largest contributor to emissions from the construction sector. In this project, we carried out both lab as well as in-field tests, and both the tests have demonstrated significant reductions in NOx as well as particle emissions. Moving on to hydrogen NRMM. Hydrogen dual fuel vehicles. This is an ongoing project with Ulemco and Balfour Beatty. 3 different types of road vehicles, which are most commonly used in the construction sector, were chosen to be retrofitted. The existing diesel engine in this vehicle can run on diesel as well as hydrogen fuel. The pilot studies aim to understand the well-to-wheel costs and emission benefits of hydrogen retrofit onto the existing fleet, as well as demonstrate the safe use of hydrogen as a fuel in the construction sector and create an awareness for the need of a UK-wide hydrogen refueling infrastructure for on-road vehicles. This technology can also be transferred to construction plant and machines used on site. Sticking with hydrogen NRMM, but moving on to the power generation. This project, the hydrogen fuel cell power generator, demonstrated the use of a hydrogen fuel cell generator on an active construction site. The GeoPura power unit is 250 kilowatt amp generators, which replaced a traditional 500 kVA diesel generator. This unit was run for roughly 6 to 7 months on an active construction site in London, and it demonstrated the use of hydrogen in construction and help develop protocols for the safe use of hydrogen on site. Since there are no tailpipe emissions from a hydrogen fuel cell, the emission benefits were quantified from coupling measured emission factors of the replaced diesel generator with the site activity profile for the duration of the project. As you can see, the role of the Center for Low Emission Construction in all of these above-mentioned projects was to provide scientific evidence in the form of independent testing and data analysis. To explain further, I shall hand back to my colleague, Dan.
Thanks, Carl. I think you can see from the sort of whirlwind tour that you've just had through multiple projects that we've been involved in over the last 2 years or so, that it's really, really important that there's independent assessment and the creation of independent evidence as we have this changing landscape for the construction sector. So as we have these 2050 target dates for net zero, and we have sort of commitments to meet those as rapidly as possible where possible, what we really need to understand is what's out there, what works and what doesn't work. And when we're in a busy, we've got such a huge amount of construction work going on us around us in the UK, often the industry itself doesn't have the time or the ability to test and understand these different solutions as they emerge. So part of the work that we're doing is trying to take these emerging solutions, these innovations, and actually test them in the field. When we're doing real-world emission measurement testing, it creates its own challenges. So we're taking laboratory-grade equipment into the field and testing it on active construction sites on machines that are actually doing the task that they were built for. And so when we're doing this, for anyone who works within the construction sector, they know how difficult it can be to gain access to the sites with the inductions and bringing in scientific equipment that isn't normally available on the sites or used on the sites, and actually then attaching it onto the machines and doing total exhaust measurements, measuring the gas flows and measuring all those pollutants in the gas on multiple test cycles to create that evidence. But really getting that evidence, like I said, is really, really important because it not only provides those policymakers with it, but also it allows easier adoption across the sites. So what does, going back to those stepping stones that we showed you earlier on, what does diesel-free look like? Well, a lot of the work that we've been doing over the last few years has been working closely with HS2 and their joint venture contractors. We've been working with bringing new innovation onto these construction sites and actually testing it and producing the evidence as to how well it performs in the real world. It gives security to the sites that if they bring an alternative fuel power generator in, that they're going to have the power that they need to run the accommodation blocks, the drying rooms, the security lighting and cameras, and charge the machines that they're using, so electric machines on the site. Through the combination approach of the trials that we've outlined and other trials that have been carried out across HS2, they were able to declare their first diesel-free construction site back in May 2022. And this was the Canterbury Road Vent Shaft site in South Kilburn. And so this was a major milestone within this project to demonstrate that actually you can achieve this. And that was partly achieved through getting early electrification to the site, so there was some grid power. It was using large pieces of electric construction machinery, such as crawler cranes, and then picking up electric tools and using alternative fuels in machines where maybe there isn't a market-ready solution that's non-diesel at the moment. Now they have 10 similar sites. So it shows that once these solutions are in place, once that evidence is there, there is scalability. You can start to roll it out across major infrastructure projects, but also across the wider UK construction sector. HS2 as a project is now committed to be diesel-free by 2029. So they see that with a route map, they can actually achieve this, and it is going to happen. The knowledge from the trials that we've been involved with our partner organisations is then captured and becomes part of the learning legacy for the HS2 process. The information, the projects that we've skimmed through today are available online on the HS2 Media channel, and also through the ICE's Learning Legacy published journal, the most recent one that came out, that gives far more detail on these individual projects, if that's what you require. We talked a little bit about the projects that we've been involved in, but what are those outputs actually used for? Well, as an academic institution, we don't just want to publish papers in peer-reviewed journals, although we do obviously do that. We want to get that information back out to the industry, and we want that information to be used to deliver change on the ground. The Construction Leadership Council have been leading on this, very much so, with a lot of industry organisations that are part of this in their Construct Zero campaign. And they've actually set a target to cut diesel use by 78% by 2035. So with the solutions that are coming through now, they're bringing that 2050 date forward for a large percentage of the contractors that are using this diesel machinery on their sites. We also understand that with the route map that's out there, that the endpoint is not just diesel free, that we need to be looking beyond that, and we need to be constantly looking out to see what is coming through, and continuing to test it in real world working environments, and actually seeing how does this equipment perform in the real world, and will it actually deliver those carbon and air quality reduction targets that we so badly need. As I mentioned a moment ago, we also have academic outputs from this research. It was essential at the beginning of this work, looking at the non-road mobile machinery CO2 and air quality contribution towards emissions in the UK, that we actually started to have some understanding of where are we now? What is the baseline that we're measuring efficiency and improved performance against? So Cole's original PhD was funded by the Greater London Authority, and working with emissions analytics, supported by emissions analytics, was able to go out into the field and measure emissions from multiple machines that were meeting the emission standards required at the moment, and were out working on active construction sites. This just allowed us to see whether the engines that were being used at that point actually did what they said on the tin. Did they meet their engine limit values? How do they perform across a range of power loads? Then we needed to understand how many of these machines are actually out there. How are they being used on sites? So starting to look at that engine activity, measuring it through the CAN bus port, and actually trying to get some generic understanding of how machines are being used across the UK. And because that's how you can understand how you can improve the performance. Some of that work led us to understand that actually a lot of these machines, particularly excavators, may spend 40 to 50% of their working day in the idle mode. So we need to understand why they do that, if it's necessary, or actually can simply switching the engine off be part of the solution at this stage for reducing carbon emissions. One of our positions as the Centre for Low Emission Construction, or at Imperial College London, is to take this evidence, make sure that it's scientifically robust, and talk to policymakers, inform them about what's actually happening, where we are at the moment, and what's going to be coming through in the future. The Greater London Authority started their process with their low emission zone for construction machinery, which formed part of their greater ultra low emission zone for London back in 2014, when they announced the policy that was started in 2015. And that's allowed them to set a minimum emission standard for construction machinery used across London. And they were the first city in the world who actually took this approach. This has been hugely successful and has allowed them to not only understand the emissions, live emissions across London that's coming from the sector and where they actually are, but it allows them to measure whether or not the policy that they have in place is delivering benefits to people who live in the city for health across the ground. DEFRA and BEIS are also looking at where the regulatory pathway should go for construction machinery, and BEIS has been running their red diesel replacement competition, for the last year or so, and this is looking at innovation and actually taking those seed ideas that can deliver change but haven't got the scale at the moment, and giving them that acceleration to actually deliver change and actually allow them to be visible and then adopted across the sites. In the 2022, the Treasury removed that tax incentive that the red diesel across multiple sectors. It was removed from the construction sector, and this was to produce a level playing field for innovation and alternative fuels to actually start getting a place on construction sites. And as we're moving around the construction industry now, it's becoming more common to see electric plant and hybrid plant are moving into testing hydrogen machinery. And so this is again a successful policy, and the second phase of that policy is about to go live, that will give some scalability to some of those front runners in this process. So a question that we often get asked is, so where's it going to go? Where does this net zero route go to? We're looking at moving from construction using diesel at the moment, using those early solutions like the HVO fuels, diesel fuel additives, and other liquid fuels that can be used in traditional diesel engines with little or no modification. So they're mature technologies, they're here, the supply chain's in place, and they can deliver some carbon saving, particularly in the carbon in the supply chain, if not at the tailpipe end of the process. But actually, where's this all going towards? Are we going to end up with an all-electric fleet, or are we going to end up with a full hydrogen fleet? And that's a really good question. When we look at the electric machines that are out there at the moment, we're seeing these across many sites. The technology is there; it's well established for those small to medium machines. But we're still seeing that really to deliver on the ground, those larger machines will probably run on hydrogen or run with hybrid engines. So they're doing some energy recovery and putting that back into the powering of the machine. If you're going to run sites on electric plant, we still need to charge them. So if we went to a full electric NRMM fleet, then we still need to have a better solution than using a diesel generator at the site to charge those engines up. And what we'd never want to see was a cleaner machine engine being displaced for an electric engine if we were using an older, dirtier generator to charge it up. So that requires more innovation and more delivery of clean off-grid energy production for the construction industry. We also need to look at what are the barriers for early site electrification. I mentioned earlier on that HS2's first diesel-free site, and part of the way they achieved that was getting site electrification. So this is essential for construction, which is obviously a very transient industry, moving around between multiple sites, to be able to have that early electrification with the power supply companies and knowing that there's a reliable source on that grid. Then we look at the hydrogen question. And I think when this started to emerge a few years ago, it was all seen as very futuristic. But actually, hydrogen is here. It's being tested, it's being demonstrated, and it's being used across construction sites. And at the moment, the questions are not about can it be done, because we know hydrogen combustion works, and we know that hydrogen fuel cells work, and we know that there are zero tailpipe emissions at the point of use. So this is clean technology. We know that with the International Energy Agency, with the 2050 scenario, that actually hydrogen could be meeting 10% of those global energy needs. And that includes the construction sector. And again, hydrogen demand is forecast to double by 2030. So we know that this is considered to be a growing solution for multiple sectors. But really at the moment, do we have the infrastructure in place? And if we do have the infrastructure in place, there's still going to be a time lag in the construction industry really understanding how to adopt hydrogen as a new fuel on site. So where they have their established protocols and risk assessments and method for use of diesel on the sites, they understand diesel, they have decades and decades of use. Bringing hydrogen onto the sites requires a whole new way of thinking and understanding of how it will be dealt with. And it also requires some policy lead from government on how it can be adopted across construction sites. Now, I hope this discussion this morning, I appreciate the fact it's a bit of a whirlwind through many, many projects that we could spend far more talking about the individual projects. But I hope it's increased your interest in the subject or raised a few interesting questions. And so I'm going to hand back to Nick now. And myself and Carl are going to stay online, and we're happy to try and answer some of those questions that you may have.
Great, thanks Dan, thanks Carl. Yeah, as you said, a whirlwind, very broad front, but some fascinating information in there. We have got lots of questions coming in, and I would encourage, there's still time for other questions, so please submit them in the chat box below. I think I'll start with a couple of the slightly more specific questions and then broaden out to the bigger picture. I'm trying to draw some commonalities also between some of the questions asked. I think the first one, a couple of people have asked about stage 5 machines, particularly in the context of retrofitting. Isn't it just easier to go straight to stage 5 machines? The implication being, and cut out the complexity of having to retrofit. What's your view on that, and what does the test data say? And I should say, I'm going to ask to both of you, I'm going to ask the questions in an open fashion, and I'll leave whichever one of you feels more suited to answer to jump in first.
I'm happy to take that one, Nick. In terms of retrofit versus stage 5, it depends on the owners of the machinery, fleet operators. There are a lot of parameters at play here. The trials that we carried out demonstrated that retrofitting an older machine can take it to well within the stage 5 emission standards for NRMM. If a certain fleet operator or fleet owner doesn't have the capability of getting a stage 5 machine, this is a viable alternative solution where they can upgrade their current fleet, taking it from older stage 3A or stage 3B machines to a stage 5 standard.
Great. And there was
if I can quickly add to that.
Please.
I mean, looking at this roadmap to net zero, and stage 5 machines, however clean they may be considered to be, and we've done quite a lot of emission measurements and trying to understand the control mechanisms within the engines there, they're still releasing fossil fuel based emissions. They're still releasing nitrogen dioxide, and they're still releasing very fine particles. Within those particles themselves, we have black carbon or soot, which is a known carcinogenic. So why stop at stage 5? Why stop with a machine that you know is still creating a health risk to the workers on your site and to the public around your site when we have cleaner solutions that are coming through? So you're completely right. If you remove a stage 3A engine, stage 4, and replace it with a stage 5 engine, you've created some benefit. But we're moving towards a diesel-free future. And so it's just a stepping stone towards that electric or hydrogen or hybrid plant.
Thanks. And there's a related question as well, which says there are claims that the newer stage 5 diesel equipment emits more CO2 than the older stage 3B. Is this true?
Happy to take that one as well again. So in terms of CO2, it depends on the engine manufacturer. It depends on the machine producer as well. We have not measured a lot of stage 5 machines and compared them like for like with the older stage 3A or stage 3B machines. So there isn't a robust data set yet of what each individual type of machine would be emitting in terms of CO2. However, if you just look at the air quality benefits, there are significant air quality benefits in terms of both. There are significant air quality benefits in terms of both NOx as well as particle emissions when you move from an older bit of stage 3A or 3B machines to the newer stage 5 or retrofit machines.
Great, thank you. Moving on to a different area, and around the, I guess, the analytical approach here. There's been a number of questions around what we mean by significant reductions or significant increases in pollutants. and Dan, you touched on it in terms of the research approach, but can you say a bit more about how we judge significant improvements or reductions? One suggestion is, do we calculate the overall air quality improvement over a known volume of fuel over a period? So what's the approach you use?
So when we're looking at significance, what we're often looking at is we're comparing new technology against displaced technology. So when we're carrying out these trials on engines and looking at engine emissions, we would look at the older, larger potentially engine that was being used in a machine, and we would measure the emissions from that. And then we would look at the cleaner engine technology. And when we take these emission measurements, the emission standards are set in a certain parameter, and we look to see whether or not there's a significant benefit to using those new engines. So it's not looking at air quality, if you like, in a time period. It's looking to see whether or not we can see a repeatable change that shows that there is a benefit and that benefit stays the same.
And do you look at, when looking at the climate change aspect, do you look at the CO2 equivalent of other greenhouse gases in your calculations?
No, we do not look at that at the moment. We are focused, the focus of the previous projects was to look at the tailpipe emissions from these machines or these products and see how they compare with the current emission standards. This is something we will be looking at in the future.
Great. Okay. So broadening it out slightly, well, there's when thinking about it more at the system level, there's been quite a few questions around hydrogen engines, and overall, how would you, I guess, characterize the potential opportunity of hydrogen internal combustion engines versus hydrogen fuel cells from I guess, an emissions and practicality point of view?
So hydrogen in terms of combustion engines and internal combustion engines will still produce some, or can produce some, emissions. When it comes to fuel cell machines or vehicles, the only output there is water vapor. So yes, there are still some emissions or tailpipe emissions associated with burning hydrogen as a fuel. However, if you look at the purity of hydrogen that is required for a combustion engine versus what's required for a fuel cell, and a fuel cell requires a lot more pure hydrogen, maybe sometimes up to 99.9%, which might not be the easiest to achieve as compared to the purity of hydrogen you require for combustion. So there is that aspect to take into consideration as well.
And does that mean that there's a lot more embedded CO2 in the production of that very pure hydrogen? Is that the primary issue?
Effectively, it could be an issue. It depends on the production process. So there are multiple ways of producing hydrogen. We all know the labels and the tags that they get: green hydrogen or blue or gray or whatever other color of the spectrum there is at this point in time. But it depends on a number of factors involved. We are not quite looking at the production side. We are looking at the on-site emissions, so to speak. So perhaps that is something that we could do in the future.
Yes, and I think that it's not a question I think you can answer, but one of the questions is around the life cycle analysis, and I think, speaking for myself, this is there's growing attention about this area, but it is a really difficult area in that there are a multitude of life cycle models out there, and often the challenge with the life cycle, it's one of those things that sounds like it's an obvious thing to do. It just moves the questions to, well, which life cycle model is the most appropriate one, and what input assumptions should we put into the model? How can we validate those input assumptions? So I think probably there would be a consensus that life cycle is something we need to look at, but it's not a straightforward solution. So in the shorter run, focusing on the point source emissions is a more proven way to go. But just to complete that area, there was a question specifically around on the hydrogen ICE engines. Have you actually done measurements of NOx emissions from engines like that yet?
Yes, we have. It was the CAGE clean air gas engine project that we mentioned previously. So that is an internal combustion engine which can run on LPG as well as can run on hydrogen. We have measured both in 2 separate engines. One is running on LPG, one is running on hydrogen, and both of those measured tailpipe emissions are compared or can be compared to standard diesel emission or spark ignition emission standards. So it gives you a ballpark figure of where we are with gas combustion and hydrogen combustion. Yes, there are no emission standards for hydrogen at the moment, but it gives you an indication of what you can expect.
And were there particular practical problems with the measurement on hydrogen ICE engines, for example, the high water presence in the exhaust?
Not that we noticed, no. Okay.
That's great. So just widening this out a bit, and one observation I would make, which the presentation made clear, is there's lots of different routes to decarbonisation. How would you characterise it, though? Is it that there is one that is either standing out or likely to come to the fore as sort of the dominant solution, or is the best approach over an extended period to be a multitude of solutions? Thinking about the parallels in passenger cars, where currently the narrative is very much around a dominant battery solution, yet this is also questioned by some, including ourselves, as to whether that actually is. So what in the off-road sphere, is it diversity where the best mix lies, or is there a likely winner?
I'll quite happily jump in on this. I think at the moment where we are, we've got to look at not only the efficacy of the solutions that are coming through, but also the availability of the solutions. So we're going to have a very diverse approach. And where we're at the moment, a lot of the construction sites in their early part of this journey have adopted HVO fuels, for instance. And we know that there'll be a potential carbon saving within the supply chain for that, but not necessarily at the tailpipe. So you don't stop at that. And as we move forward, there is no clear single silver bullet that's going to solve the problem for the construction sector. So it is going to be a multitude of approaches. And as we mentioned earlier on, when we're looking at things like the competition that's being run through government, through BEIS, there's technologies that haven't really hit the ground yet that are being tested. So I think it's very hard to say this is going to be the sole solution that's going to solve the problem for the construction sector, where we really need to kind of be aware of what's coming through, testing that, and where there's a definite benefit, and where there's a benefit for both air quality and climate change, and where there's potentially a benefit in fuel savings, so there's cost saving, or there's higher savings for the sites, that we're putting those through, so that there's a wider adoption of solutions that have the biggest benefit.
Great, thank you. There's a paradox, it seems. One of the big disadvantages of batteries for passenger cars is the weight of the batteries and the fact that you're only using a relatively small proportion of the battery on a typical journey. Essentially, the battery is being sized for occasional long journeys. Whereas actually in off-road, we don't have those same problems. In the mass of the batteries is less of an issue. Because we're not moving them around so much, and the duty cycles are probably better understood, and you can use a lot of the battery most days. So I put that out there as a challenge. So the question would be, why actually isn't batteries coming to the fore as a more dominant solution in off-road, even more so than in mobile transportation, in your opinion?
I think at this point, it would be best to have a technology neutral approach if we have to learn from the past. We all know the UK government went down the route of diesel engines for passenger vehicles. It would not be wise to put all your eggs in one basket. So at this point, because it's early stages and early phases, we could see an approach where it's a mix of different technologies that are used based on, as you mentioned, DD cycles. So smaller machines could be operated on electric and batteries because the DD cycle demands that they can have a smaller battery on there, which can be operated for the 7-8 hour work shift. And the medium and large plant can be operated on combustion engines, for example, fuels such as hydrogen. So it would be wise, in my opinion, to have a mixed approach or a hybrid approach encompassing all different types of technology instead of backing just one horse.
Okay, thank you.
Have to consider as we're moving, the electric plant market is becoming well developed, but it is very much around how these machines are being charged and how they're being charged off grid. And if we're just displacing one engine to use another engine to produce electricity on sites and releasing those emissions, we haven't gained anything. So we need to be having, this is why we have to look at these multiple solutions, and very much the big focus on power generation. We're seeing power generators are often, they're not obviously the most common machine on construction sites, but because of the sizing of the engines, the age of the engine, and the activity of running them 24/7 to provide power to the sites, they're often the highest emitters on sites at the moment. If you then have a requirement to charge your electric fleet overnight, we need to have those clean solutions for charging. And that's going to be a combination of using maybe hydrogen fuel cells, of using some grid electrification, and using other renewables that are out there. So there are solutions that are there, but it's about adopting them, testing them, proving that they work, measuring the impacts, scaling it across the UK fleet. So actually saying, if we were to change from a stage 4 excavator to an electric excavator and have clean charging, what would be the impact across the emissions for the whole UK fleet? So we started off talking about those figures for carbon emissions from fuel burn on construction sites, from both the engines used in the machines and the generators. How do we bring that down to net zero?
Okay, thank you. And another aspect of that is, do you see a role for e-fuels together with advanced emissions after treatment systems? E-fuels is the controversial question on light duty at the moment. Where is that in the debate on off-road, and what's your view on that as a potential route to decarbonisation?
At the moment, we haven't had e-fuels penetrate into the off-road sector. This is not something that has come across our desk as yet, so to speak. It would be interesting to see what the benefits or the advantages are of these fuels in this off-road sector. So we're always open to a challenge and to see not just back one technology, but see what else is out there which could be applicable to the sector.
Okay, thank you. Then we've got a question around adoption. If machinery manufacturers offered their products as part of a service deal that included the cost of the fuel, how do you think this would impact their powertrain choice and the decarbonisation pathway? So it's an interesting one.
It's a very interesting question, and I don't know that we necessarily have the answer to that. I think that as we're looking to see the adoption, and there's a huge amount of research and development being carried out by these OEMs and machinery manufacturers, they need to explore that with their end users as to how they promote the adoption.
And it links potentially to another one, because from my view, how you affect the marginal cost of operation is the interesting, and how that then changes the operator's behaviour. And there's a question, I hope I've interpreted it correctly. It says, will the use of NRMMs, so I'm assuming the equipment, increase or decrease as the construction sector adapts to net zero operation? So I interpret this as, does this mean either the utility limitations or the marginal cost of operation of it, is this likely to lead to more or less activity?
Again, so it's a very good question. What we're seeing in the UK is obviously we have major infrastructure projects that are using a lot of the construction resource within the UK, but there's a huge amount of development. Where we're based in Imperial College in White City, I stand up in the 10th floor in a glass wall building, and I look out across London, and I can't look in any direction and not see just tower cranes in all directions. We have a huge amount of development going on around us. I can't see that we're going to be using less machines in the future to deliver those projects that are going on around us. How the machines are being used in the future, there's huge changes in the non-road mobile machinery market, not just in the fuel use, not just whether it's electric, hybrid, or hydrogen, or running on other fuels, but actually we're moving towards autonomous machines, and we're moving towards remote control machines, and maybe there will be changes coming through where machines, you'll have less machines on site that are capable of doing more jobs. But at the moment, I don't really know too much about that to comment.
But from your experience of working with these various operators, I mean, there's a question in the chat about the total cost of ownership. Do you find that operators are looking and using total cost of ownership as the primary metric, or is it more the marginal cost of operation, subject to meeting whatever considerate constructors scheme requirements there are? So is it very much a on-site marginal decision making, or is there more of a move to a total cost of ownership approach?
I think each fleet operator would have their own business model, so to speak. So it depends on their fleet composition, their fleet size. What are they more involved with? Are they involved with demolition phase of a project? Are they involved with the latter stages of a construction site? It depends on where they would see their most benefit lies. So I think it would be pushing this question back onto them to explore further there isn't a one size fits all solution out there. So it depends on each operator and each fleet owner, so to speak, to explore what would be the best solution for their current business model.
Okay, fair enough. Returning to the battery electric question, there's a challenge in the chat about actually how much of a limitation is the grid for recharging. So even if we're building in a very remote area, how much of a limitation either now or in the longer run is this? I think we have to put this in the context of the grid is going to have to be built out anyway to support the electrification of light duty. So do you see that would also solve the problem of charging up off-road equipment, and would that then put battery electrification for off-road in pole position? So effectively, is there a synergy between off-road and on-road in the infrastructure build-out?
Possibly. I mean, I think when you start talking about remote sites, that there may be a longer term plan to run them on off-grid power, and that's where we need to be looking at adopting renewables and clean energy production locally to the sites. I mean, I guess where we're at the moment, my own energy supplier is asking me to have low energy use periods because the grid is not strong enough to support the domestic use on it. So if we moved all construction machines to recharge on the grid, do we have that resource and resilience within the existing grid as it is, and how are we producing power on that grid? So I don't think that this problem is going to go away short term. So we need to be looking at those as we are, the innovations that are coming through, those cleaner power supplies, and how they're being utilized and how to make them more efficient. And going back to the earlier question about total cost of ownership, and looking at scale, as we're seeing kind of wider uptake of hydrogen, for example, then the cost point is going to come down. Once that infrastructure is in place and we're able to fuel these machines more efficiently, and we know how to do it, the cost point is going to come down. So I think that model is going to change. And so I think it's very hard to base it on today's prices. And these things shouldn't be barriers. When we mentioned earlier on, you know, the 6.7 million people a year dying prematurely from poor air quality, and then looking at worker exposure itself within the construction sector, looking at illness registrations from the construction sector, actually should cost be the barrier to adopting cleaner working practices.
Fair point. Again, linked to that, there's a specific question. Is a genset running at peak efficiency, i.e. used purely for charging a battery than managing a variable site load, is that not more efficient and better emissions profile at stage 5 than using variable speed engines on the machines themselves?
It comes down to duty cycles. So we talked about different machines having different duty cycles. For example, generators tend to operate 24 hours a day. Other machines and other plants tend to be used for an 8-hour work shift. Within the 8 hours, again, they might not be working all of the time. So it depends on the load cycle, the duty cycle, what is, each machine is built to do a specific task which differs from the other machine. In terms of charging up a battery, if you're using the battery and just depleting the battery for most of the work, charging it up, how much time is spent to charge up that battery by using that engine? So it's the time spent, the duty cycle, as well as the emission factors of, is it a stage 5 and a cleaner machine that is used to charge up the battery? Or is it a cleaner machine that is digging a hole in the ground next to it?
And so, yeah, just to add to that, I mean, this was some earlier research that we carried out with emissions analytics back in 2015, where we worked with Speedy and we measure emissions from a range of generators within their power depot to create those emission factors, to get those load profile curves, if you like, for different pollutants, so we could better understand where is the sweet point for emissions within those load cycles. And once you've got that, as Carl just mentioned, understanding duty cycles, understanding load demands, and then actually not just going for the biggest generator that would give you a lot of contingency and running it wherever it sits, but actually starting to do a bit of smart management and making sure that you're matching your power generators to your load demands, so that they're actually giving the lowest emissions when they're working.
Yeah, which all points to a diverse range of solutions, depending on the situation. Okay, we're running out of time, so I just one very last brief question, which is in the context of the health impact. What is the relative impact of the particles from the exhaust of the plant equipment compared to that generated from the, from the dust from the construction activity itself? Can you give us any idea of orders of magnitude on that one?
I can't really give you orders of magnitude, but when we're talking about particles and particle size, a grain of sand is a great EPA slide, but a grain of sand is about 90 micrometers across. A human hair is about 70. And the stuff that we're measuring coming from construction sites are PM10s, PM2.5s, and PM1s. These are the invisible dusts in the air. When we look at that fugitive dust, whether it's from concrete breaking, whether it's from track out that's been resuspended, that tends to be on the coarser end of the scale, and therefore it has less pathway into the body. So it is those very fine particles that are coming from engine emissions. And even with the stage 5 engines, where you have after exhaust technology on those engines, you've got particle traps, you're still getting a very high particle number of fine particles that are potentially far more toxic. So they not only travel further into the body, but they can have far greater health impacts. And I mentioned carcinogenics earlier on, but actually we look at where the epidemiology is going with this, and we're looking at the health risk based on the organs that they're reaching in the body. So they're not just impacting the lungs, as maybe the coarser dusts would do, but actually they're impacting the heart and the brain and other organs on the body. And we're seeing a whole host of illness caused by those. So we really need to move towards that diesel-free future to protect public health.
The first question I wanted to go to was a very specific one. How were emissions from retrofit solutions measured in order to be able to compare them with the stage 5 limit values?
Interesting question. I can take that one, Nick. So for that particular trial that we did, we worked with emissions analytics. They had a portable emissions measurement system that we stick onto a machine, and we do a pre and a post retrofit trial or test. We develop a test cycle with the manufacturer of the machine or with the test site itself, so that we have repeatable results and a repeatable test cycle both before and after, so pre and post. We use these PEMs to measure the tailpipe emissions. We also use flow meters to measure the mass flow. The concentrations and the mass flow are coupled together to give a flow rate in terms of emissions. We are also monitoring the engine power output during each mode of operation or each mode of activity. For example, what is that piling rig doing? Is it drilling a big hole in the ground? Is it idling? Is it moving from one place to the other? All of those produce different emission profiles and different engine power outputs in terms of kilowatts. So once we have those three parameters aligned, we can then assess what the emissions are for different activities, which are then compared with the emission standards or the EU emission standards, which are in grams per kilowatt hour.
Great, thank you. Moving on, there's quite a few questions, as there were this morning, around hydrogen. First question is saying that my research to date has shown that if hydrogen is combusted, more NO2 is produced due to the higher combustion temperatures. Can you please share your test results comparing combustion of hydrogen to diesel?
Yes, another fantastic question. The CAGE clean air gas engine project that I mentioned, as I said, we tested both in the lab or in a test cell, as well as out in the field. Yes, combusting hydrogen can produce unwanted levels of NOx or NO or NO2. It's to do with the thermal management of the engine, but these have been, the map of the engine is such that you can control for this NOx. I'm more than happy to share the results from this trial, both out in the field as well as in the test cell.
So should I take from that that for hydrogen engines to work at a sufficiently clean level, it is necessary to have fairly advanced after treatment systems on that engine?
Not always, not necessarily, not all the time, but it is vital to make sure or to ensure that you are within the limit values, so to speak. So it's all about thermal management.
Okay, understood. Again, on the hydrogen diesel conversion you presented, a question was, what was the substitution rates in terms of energy and also on a volumetric basis? And were those rates steady state or transient?
So I mentioned that that's an ongoing project, and the ULEMCO one, where it's retrofitting a current diesel engine to operate both on diesel as well as hydrogen. In terms of the injection rates and all other parameters involved, this is, I'm guessing, proprietary information from the company itself, which I don't think we would be able to share. But once we have measured the emissions and the report is published, again, more than happy to share the results from those trials.
Great. And in terms of trials, the ongoing ones, future potential trials, one question is, are there any considerations to include OEMs for these tests? I know on the ones we've worked together on, OEMs have been involved in some way, but if you could, what's your general approach to having OEM involvement?
Yes, Nick, in the past, we have worked with OEMs, as you're well aware of. I don't want to name drop at this point, but certain OEMs are more willing to help than others. OEMs do want to help. They do wish to be involved at every process or every stage of the process. It's not like we've got pushback from any OEM such. However, the nature of our testing is that we provide independent analysis and reporting. So we see what these machines are doing once they are out on site. We don't necessarily go to an engine manufacturer or test with them in their test cell or lab cell. We see what the machines are doing under a real world profile, a real world activity, and out in the field.
Yes, and we've seen in so many times over the years why that's a really important counterpart. So cooperation with OEMs is important, but equally, doing it in the real operational conditions is vital. There's a question about costs here. So what cost comparison data have been developed, including new machinery costs? So I interpret that as broadly as, across all the different possible routes. Can you give any indication of which ones are the most cost effective or most cost efficient in delivering a unit of CO2 reduction, perhaps?
So at the moment, the work that we've been carrying out has been looking at the emission reduction benefits of the different solutions that we have tested. So we haven't been doing the cost benefit analysis. And I think particularly when you're moving into the hydrogen sector and you're testing those engines, at the moment, what we're really doing is demonstrating that these engines work, that they can give the fuel security to the sites, rather than is there a cost benefit to displace diesel and replace it with hydrogen at this point. So that isn't a piece of work that we've done at the moment.
Okay, thank you. So widening it out slightly, I mean, my observation here is that we're pursuing multiple routes to decarbonisation here, and one of the other ones that has been raised in the questions is e-diesel. So have you tested? I interpret that as sort of pure synthetic diesel. Is that something you've tested previously or planning to in the future, and what potential do you see around that?
This is not something we've tested previously. However, we would be open to go down that avenue. Like I said, it's not a one solution for decarbonization. So we are more than open, more than willing to test all the possible solutions out there to see which is the most viable, or perhaps a mix of all of them, which would be the most viable to get us to that decarbonization targets.
I mean, of the fuels tested so far, which would you say was the lowest embedded carbon overall? So what's the closest? Would it be HVO or one of the other fuels?
During the trials, what we have done is we measure the tailpipe emissions. So we are looking at point of use and associated emissions when you are burning that fuel. For a lot of biodiesels, the potential carbon saving is from how you source such fuels. In terms of embedded carbon, we haven't yet done any analysis of such. So at this point, it would be difficult for me to give you an exact answer onto which horse has won the race.
Sure. And bio-LPG, that's also been raised. Is that something you've looked at? The suggestion here is that has been able to deliver significant air quality improvements and CO2 reductions. Do you have a view from any of your work on bio-LPG?
Yes, the CAGE technology, the CAGE engine, the clean air gas engine, which is a multi-gas engine, as I mentioned, it works on or can be operated on LPG as well as hydrogen. However, if bio-LPG is available, yes, that technology can also be used to burn bio-LPG. And as a matter of fact, the manufacturers are running certain units of their technology on bio-LPG in Africa.
Okay, great, thank you. Back on hydrogen again, a specific question. How much of the hydrogen test used green hydrogen, which is obviously in limited supply at the moment? So what proportion was really green?
So as far as I'm aware, during the trial with the GeoPura units, the hydrogen that was imported for that trial was green hydrogen. At the moment, this is like I say, these are demonstrator projects rather than running sites long term on the hydrogen. And that's one of the things that we mentioned during the presentation is you can prove the technology works, you can measure the emissions, you can show the reductions are there compared to the displaced technology, those diesel technologies. And then it's really down to the government to start putting in the fuel infrastructure so that we can actually start to move away from diesel dependency within the construction sector and move to these cleaner alternatives.
Fair enough. And with the hydrogen ICE engine, a specific question on what was the lambda and the fuel injection system. Is that something that can be shared?
Unfortunately, no, not at this point. Again, that would be a question for the manufacturers and the innovators of that technology.
Okay, fair enough. With the alternative fuels again, the question is your experience that OEMs are willing to honour the vehicle warranties when using alternative fuels?
I think quite a lot of OEMs now, if you're moving to a slight straight drop-in replacement fuel, I mean, obviously it will be a discussion to have with your individual OEMs, and I can't give you endorsement today and say they will or won't, but have those discussions. Obviously, they know that the market is changing, their market is changing. So it's a discussion to have with them. But yes, as far as I'm aware, I've not heard anecdotally of any warranty being invalidated because someone's used a drop-in fuel in those engines.
And I guess I can add from our side and wider work as well, it looks so whereas on paper certain fuels might not meet the warranty requirements, I have not heard of where proper quality market fuel has been used of actually warranties been in practice invalidated. Okay, and then a wider question about sort of market and adoption. Question, not all types of construction machinery are available as electric, hydrogen or hybrid. Can you comment on how to get more types of OEMs into the market?
Well, the market's driven by demand. So where we don't have a UK-wide policy at the moment, but there are regional policies. So we talked about the Greater London Authority and their ultra-low emission zone and the low emission zone requirements for construction machinery. That then drives the demand for cleaner machinery. So as we're seeing more demand for these, and the battery technology is advancing, and that's how we're going to drive change in the market. So it really is by end user demand.
Understood. And is there a working group of people within the construction industry within which ideas are shared? Is a question.
So again, I mentioned during the presentation, the Construction Leadership Council have been working with their industry partners, and so there's been this kind of cross contractor and group who've all been inputting ideas. That output's been out for consultation for the last few weeks and will be published quite soon. But yes, there are working groups, and again, I said before, there's no silver bullet, but
this is going to be a long and evolving process. I'd be interested in both your views on, do you think over time, we're clearly at a stage at the moment where there are multiple potential solutions. Over time, do you see this narrowing down to one or two winning solutions? And if so, which ones do you think there might be? Or do you think the solution to construction emissions, it will remain forever multivariate because of the highly variable nature of construction itself? What would be your view?
Good question, Nick. In terms of construction, a lot of it is driven by activity profiles. For example, different machines perform different tasks. So generators tend to run 24/7 when they're on site, whereas other machines like piling rigs or excavators perform an 8-hour work shift. Based on that activity profile, you can then see a pattern developing where if you need to use something for a shorter period of time, then perhaps a more battery hybrid approach might be applicable. This might also be applicable to the size of the machines. So for smaller machines, whereas the medium and the larger plant might move towards hydrogen or some form of gaseous fuel. So at this point in time, I would say you wouldn't want to put all your eggs in one basket. The government itself is taking or should be taking a technology neutral approach so that we don't have learning from past mistakes. We do not just back one particular type of combustion where it went down the route of diesel combustion for the on-road sector.
And Dan, what's your thoughts on that?
I very much agree with Carl. I think we need to have a multiple approach to how we're dealing with this. As we said previously in the presentation, there is no silver bullet. There is no instant solution. And as the competition's being run by government, run by BEIS, looking at new innovation, we don't want to write anything off by narrowing it down and saying this is the route that we're going to when there's new potential solutions coming through. So yeah, I agree totally with what Carl said there.
And if I may, I mean, question that's in my mind is you both very strongly said there's no silver bullet, but in the passenger car segment, we're very much being told at the moment that there is a silver bullet, that's electrification. Yet some dissenters see the inherent inefficiency of carrying around a very large thing, the battery, long distances, and where you're not using quite a high proportion of the battery capacity a lot of the time, because most journeys are very short. Construction seems to be a more suitable use of batteries in the distances, things are often static or traveling only very short distances, and would use the battery capacity, all of it, every day. So on that level, it seems that construction should be more suited to battery electrification than light duty. But clearly there will be reasons why that's not the case. What do you see the main things holding back electrification in construction settings?
So we see a lot of construction machines coming through, particularly in the smaller and medium-sized plants at the moment. And this is a real advance. But when we're looking at these construction sites that are working on off-grid power supply, the big question is then about how is this actually being charged up? And when we're looking, we mentioned diesel generators earlier on, and that they are a major contributor towards NOx and particle emissions from construction. If we're displacing those diesel engines in the excavators and telehandlers and other machines being used across the sites, replacing them with electric engines, and then having to have a large diesel generator running on the site to charge up the plant overnight, we haven't really solved the problem. We've just taken a sidestep. So the clean power generation for the construction sector is as important as the actual where we're going with the hydrogen or the electric plants.
Anything to add from your side, Carl?
No, just more of the same. It all depends on if you've got these electric machines on site, how do you charge them up? So do you have access to a grid connection, or are you then using a dirty generator to charge them up? So that is the primary barrier.
Understood. Great. Well, I think we're drawing towards the close. There's still a couple of minutes left if there's any final questions. I think we've covered most of the ones posted. There are a few around the how clean hydrogen really is and the provenance of it and the genuine sustainability of hydrogen. But I think we've covered that off to some extent, and that it possibly is not, unless you want to jump in, you may not have any further comments you want to make on that. It's clearly a topic of debate and a somewhat controversial one at the moment, but that may well be sort of out of scope of the work you've been conducting. So I'll give it last chance for anyone to submit any questions. Otherwise, I think we'll draw to a close. I will just do a final check to make sure I haven't missed anything important. A hydrogen storage question. Yes, well reminded. So there is, what about the COMA regs and the limit of hydrogen storage on site? Do you have, and that is I'm assuming by there, a barrier to adoption or a logistical problem that presents?
Yeah, and this is a genuine part of the process of introducing hydrogen into any of the sectors. So where you have a sector that has very well established protocols around diesel use, the supply chain bringing it onto the sites, fueling the machines, storing it on sites, hydrogen's a completely new set of requirements for the sites. And so when we're running these demonstration projects, that's very much also part of the learning process around these. So we don't have the answers to that at the moment. That's still work in progress, but it's being addressed.
Great. Okay, well, thank you, everyone. Thank you, particularly Dan and Carl. Really appreciate sharing this information with us. Thank you to everyone who's attended for the large number of questions. And all that leaves me to say is look out for the next emissions analytics webinar. We're aiming to do one on the tailpipe emissions of VOCs from renewable fuels. So has an interesting overlap in on-road applications as well as off-road, but how these innovative fuels are potentially leading to certain tailpipe pollutants that are not currently regulated. So watch out for that. Hopefully we'll be doing that next month. But Dan, Carl, thank you again. Thank you to everyone. I hope this was useful, and we'll see you next time. Thank you very much.
Thank you.